I'm Shastak Lanka. This is the fifth video in this tutorial and I'll explain about frequency divider and counters in this video. First I explain frequency divider. What's frequency divider? Frequency divider is module that reduces the frequency of the signals. There are three types of frequency dividers and those work with sequential waves and work with sinusoidal signals. This is the basically type of frequency divider and it's run on this type. And when we input this type of signal and out comes is this type of signals because it's divide this first signal divide by any value and output is this. Then when we create frequency divider using JK flip-flops and its concept, normal concept is ripple counter. It has ripple counter concept, and if you want divide first frequency as we wish how many times we have to know that type of JK flip-flop for that circuit. Then and this is the practical session and practical circuit. This is circuit normal basically circuit of the frequency divider. We can use this concept and this is the frequency divider timing diagram. Let's move to the frequency logic simulator tool in Logisom, and this is I already created that circuit. This is the type of frequency divider and I use 1 2 3 4 JK flip-flops and input signal I divide by 4 times and one first divide and its input to when using frequency is consider the F. This output is F divided 2 and second is F by 4, F by 8 and F divided by 16. This is the output and its a final output is this one and first output connecting second JK flip-flop, second output connect third JK flip-flop and third output connected to the final JK flip-flop. Then we have to when we run on this program we have to constant value for those other inputs. It must be a 1. Then we can change clock pulse. You can show how to run on that. Now you can show this is the implement and this is a run type of frequency divider. And what this simulator tool have that facility timing diagram. I'll show that timing diagram in the another uh, simulator tool. Then it's a website tool and I'll already created that and I'll explain. This is also frequency divider. Check this as a 4 JK flip-flops. Before I explain about the JK flip-flops, and this input is a 5 volt and it's not a and this is asynchronous one and this is the decimal display area and I run on the run this. Now you can show timing diagram. This is the first input frequency, second output, third output and final output is this one. Now you can show in the in the mouse pointer in fourth line you can show blue color in that line. This line is blue color. When I input when I in the mouse pointer in these lines you can show which line represent from that line. Now you can show it's a blue color, green color change to blue color. Okay, this is the frequency divider and frequency divider timing diagram. This is normal concept and I think you know about frequency divider basic idea. Then I move to the second topic. It's a counter. Counters are BCD counter and decade counter, binary code decimal. It is a serial digit counter that counters 10 digit. It explain and if we want to input one decimal value and you can represent A B C D in the binary code 1 and 0. When we use in 1 and 0 you can represent that related value from that input. It is a counter timing diagram. This is the counter the timing diagram. This also same type of same concept in a JK flip-flop using a frequency divider. It's related frequency divider also related this counters, and this counter synchronous and asynchronous. Synchronous and asynchronous means when we using a counter we input clock values for that, then it's a synchronous, and if not normal input we use then call asynchronous. Those synchronous and asynchronous counters as different because synchronous counters faster than asynchronous counter because of that clock pulse. Those flip-flop sensitivity is faster than clock pulse and normal sensitivity than clock pulse and normal signal more than normal signal. And I'll show this the BCD counter and decade counter can be considered from straight binary counter by terminating repeat through counting when we counter reach decimal 9 and decimal 9 plus 9 plus binary code is 1001. This is the normal one. Is it's connected NAND gate and that NAND gate contains CLR, and I'll show that I already created that circuit. It's a date counter. It's a date counter. When we input this one, normally we can change 1 and 0 to the output. Now you can show it's a clock pulse and change. You will show that outputs also change. Now you can show it's those counters, those JK from these counters sensitive leading edge and trailing edge. I'll explain leading what is the leading edge and trailing edge, and now you show those inputs and outputs are changed. This is the concept of the decade decoders, and I think finish that. Those are the frequency dividers, and thank you.